1. Okay, so the negative 1 is like what goes there, because that's the a. Okay. And then if you want to solve for b, just pick an x that like would cancel the a out, you know? So pick x being like negative 1 or something. So maybe I'll just do let x equal negative 1. So then I get negative 1 minus 7 equals a times negative 1 plus 1, which will cancel the a out, which is the point. And then now I basically am solving the same thing, but it's for b. So I get negative 8 and then negative 4b. So 2. So then 2. So it's really algebra-y, because I didn't even integrate yet. I'm just like doing this stuff, and then now it's like I'm fresh, and now I can integrate this, which is hopefully theoretically easy to integrate because it's just natural log. Chain rule if you need it. So like to integrate this, you would get, here maybe I'll like, don't look at this, okay. This would be negative natural log of x minus 3 plus 2 absolute natural log absolute value of x plus 1 and plus c. And then you're done. So most of the work isn't even in integrating. It's just like getting into the form. And then you're just natural logging with whatever numbers on the numerator. So this is the negative 1. And then here's the 2, you know. If there was like, let's just say this was 5x minus 3, just to remind you, that would be negative 1/5 in front. So if this was a 5, you know, you would have to, don't forget chain rule, in case this is like a 2x or something like that. I think I have an example like that we could do. Oh, the next one. Good job, past self. Okay. Anyway, so now this guy, same thing. So what you're gonna do is like reverse common denominator kind of. So first thing you do is hopefully we can factor this thing. Oops. So, gosh, that x messes up my life. Do you know what I mean? Can't factor out a GCF, you know what I'm saying? That would have been nicer, but I can't. Okay, so I think it's 2x and 3x is my guess. And then 3 and 4, is that right? Yeah, plus minus. Okay, so you factor it, so going back to yesteryear, you know. And then now what you're gonna do is you're gonna have to come up with those numbers and put it into that like form with the negative 1 and the 2 kind of idea. So what I'm gonna do, and again, you don't have to show this, like the algebra step I'll show you, but it's essentially you're clearing the denominator. So you're gonna have an a over, I'm gonna be consistent. Oh, I did 3x minus 4. I did the 3x minus 4 first. I'm just going to be consistent with my notes. And then b over 2x plus 3. You could have them switched. You still get the same answer. I just want to double check my work as I'm going through here. So again, what you're going to do is clear the fractions. So again, you don't need to show like that you're doing this, but like this is what's happening. You're multiplying by 2x plus 3 times 3x minus 4 on both sides, basically. Because then that'll clear your denominators, okay? And if you notice, there'll be a pattern. You'll notice it, but like A is going to have the 2x plus 3 with it, and B is going to have the 3x minus 4 with it. So you're going to get 5x minus 4 equals, and then you're going to have A times 2x plus 3 and B times 3x minus 4 for the way I set it up. So then this part is where it's like annoying because it might take a little bit more brain power to figure out what x should be, but it's essentially you're like, okay, what value of x would make this stuff by b 0? Do you know what I mean? So it would be 4/3. Because if x was 4/3, then it would cancel b out. So it's essentially like you're setting this equal to 0 is when you're solving it. So like, maybe so like, I don't know, I'm going to let x be 4/3 because that would clear the b. So this is where it's like painful because you have to do fraction work. So it will drive you insane, but I'm just going to write b times 0, okay? So 0, you know? And then you hack at it, you know? So unfortunately, the quiz is no calculator, so I have to get used to all that fun stuff. So that'd be 8/3 plus 9/3. Little math tricks. Okay. I did kind of multiply common denominator at the same time-ish, kind of, okay? And then once they have the same common denominator, think you're multiplying both sides by 3. That's what I would do, because then you clear the fraction. I clear the fraction as fast as possible. And then this is where you get anxiety, because you're like, this is kind of a weird fraction, but that's normal. So if you're getting kind of like sassy fractions, it's probably going to be okay. It's just kind of nerve-wracking. Okay. Okay. So again, like going back to like the goal here is to rewrite the integral into this 3x minus 4 plus 2x plus 3 dx thing. That's the goal. I got the A. And it's like ugly and yuck. Ugh. But it's fine. It'll be easy to integrate. Okay. So now you're going to do B. So to solve for B, what does that have to be? So I got to nix the A, right? So I need all that junk in like by A to equal 0. So that would equal -3/2, right? You set that equal to 0. So like if this is -3/2, that'll give you a 0 in front of A. So I'm going to write -3/2 because then, oh boy, now we have negatives to deal with. Isn't this more fun? -3/2 minus 4 equals A times 0, which was the point, plus B times 3 times -3/2 is 4. And then, here we go, common denom. So what is this? -15/2 minus 8/2 equals B times -9/2 minus 8/2. Let's make everything negative because that's fun. Okay. What is that? -23, right? And then that would be -17. Ew. Right? It's freaky because you're like, these look kind of scary, but it's normal. So I'm going to multiply both sides by regular -2. So 23/17. Totally normal. Okay, is my B. Okay, so I'm going to do 23 over 17. Okay. All right, but when you do the antiderivative, you cannot forget your chain. That's a 3x and a 2x, which means you're going to have to multiply by a half and a third when you're integrating. Or you could do a full-on U sub, but I think you guys are smart enough where you don't need to. I think so. You guys are pretty smart, you know what I'm saying? So this is the, the A thing. And then this is what I'm saying. You got to multiply by 1/3. So I'm just going to show this because that's the thing that people mess up. And of course, AP gets you on it. It'll be a choice where they don't have the chain on it because they're beautiful people. Okay. So just be careful with the chain that you're going to have to do the third here. Okay. And then plus, and then we got this goofball, 23 over 17. And then don't forget to chain it with the 1/2. Okay. And then natural log absolute value 2x plus 3 plus c. And then you would clean it up. Okay. So just don't forget chain because they'll try to get you on that. What's 3 times 17? 51. There she is. It's kind of satisfying, right? Kind of? Hey. Any questions at all? You know how we did A, B? Why don't we do C? You know? Like, why don't we do 3 fractions? You know what I mean? Because look at, that one's so easy. Like, I should just know what the antiderivative of it. Wrong, just kidding. Partial fractions, horrible. Okay. Why? Because the numerator is denominator, is factorable. So, also, I don't like when dx is on the numerator. That's just me being a little psycho, but I really just don't like that. I like when it's 1. Because, okay, cool, you take out an x, right? GCFer. And look at what you're left with. Oh, what a nice little fracturable little guy there. You know? So I'm like, all right. Let's keep her going. And now I got 3 of them. So, this is going to be great. We're going to get an A, B, and a C. Okay. So, last one. I guess I'm just showing you all the algebra because why not? We're no. Okay, so this is what we got. So I'm going to do an A with just a little x. Okay. Then I'm going to do a B. I'm going to be consistent with my notes. X plus 1. And then I'm going to do a C. At least it's rainbow. Got to think positive into that. You're going to clear denominators the same way, but the stuff next to your A, B, and C is just going to be like more stuff. If that makes sense. So like, you're still going to multiply by x times x plus 1 times x minus 1. You can read that, right? Okay. And then you're going to multiply this thing, same thing. To keep it legal, right? Multiply both sides by the same thing. So, all right, 1 positive. This is just 1. Okay? That's good. Okay? Now, if you, again, think about it. If you were to distribute this, the only thing that would cancel out are the x's. So next to A is all that, the x plus 1, x minus 1. Two things? Yeah. And then same with b. So if you're going to distribute it, the only thing that would cancel out is the x plus 1. So what will be left next to the b is just the normal x and then the x minus 1. Oops. And then c, only the x minus 1 will cancel. So you're left with the x times x plus 1. Okay. Now, again, if you want to clear it, it works out. Because, like for a, if I want to solve for a, I'm going to let x equal 0. Because, do you see how that'll mix your b and c? Because they both have them times x. So it'll work out. It's just longer. It's just longer. You know. That's all. So I'm going to let x equal 0. So I get 1 equals a, 0 plus 1, 0 minus 1. And this is what I'm saying. You'll get 0b plus 0c, which is the whole point. Okay? So it'll clear out the other guys so you can solve for just a. And then this is where the negative signs are going to freak you out. Because you're going to be like, okay, wait, 1 equals, 1 plus 0 is 1, okay, and 1 times negative 1 is negative 1, so it's negative a. So negative 1 is a. Okay. Here, I didn't even start my integral going here. So I want the goal again is to get it like this. And I got one. Yay, got one. Okay, now we're going to go for B. So for B, what do I want to get rid of? So A and C have the plus ones, right? The x plus ones, B doesn't. So if I want to nix B, if I want to nix the A and the C, I want to let x equal negative 1, right? Because that'll get rid of the A and the c. So I'm going to let x equals negative 1. So I get, wait, 1 because it was just 1. And then this is 0a plus b times negative 1. And then negative 1 minus 1. Okay. And then plus 0c, which is the point. Okay. So I get 1 equals 2b, right? Positive 2. So a half. Okay. And then you were like, well, now I get to use my blue pen, you know. So for C, what will nix it? A 1, probably? Yep. Okay. So again, clear everything out with your magical number. Okay. Some colleges teach partial fractions with factoring by grouping. I think that's harder than necessary. This does get more intense if you have to take Calc 2 next year in college. BC doesn't get that much harder than this. So that's the advantage of taking it. All right, so 0a, 0b, and then c times 1 times 1 plus 1. So a half again. Okay, so then we do a half. And then you integrate it. So if you integrate it, it's negative, and then natural log absolute value x plus 1/2 natural log x plus 1 plus 1/2 natural log x minus 1 plus c. And that's partial fractions in a nutshell.